Elemental analysis is the process by which we determine what a sample is composed of. We can either figure out its percent composition or determine its molecular formula. Below are the steps for determining the molecular formula of a sample. The first thing we have to do is write out a generic formula. For instance, if we're told that something only has carbon, hydrogen, and oxygen, its generic formula would be CXHYOZ. And we will eventually figure out numbers to put in the place for X, Y, and Z. These numbers will be whole numbers, for instance, 1, 2, 3, etc. If we had a compound and we were told it only has iron and chloride, then its generic formula would be FeXCl. Now our goal is to determine what numbers to put in place for X, Y, and Z. And we can do this by determining the number of moles of each element in the sample. How do we do this? Well, step 2 is if we are given a percent composition, we convert that to grams by saying, let's assume that the sample is 100 grams. So if we were to do this and we were told that we had 10% carbon, well, if we had 100 grams total, that means we would have 10 grams of carbon. Step 3 is we convert from grams to moles using the molar mass. And once we have the number of moles, we can determine the empirical formula, which is the simplest whole number ratio. And then finally, we can find the molecular formula. And to find the molecular formula, we need to be given the molecular mass. So let's go ahead and let's look at this process. Let's say we have a sample of an unknown compound and it contains 50% carbon, 5.5% hydrogen, and 44.5% oxygen. We're told the molecular mass, and we want to figure out what that molecular formula is. All right, so we have carbon, hydrogen, and oxygen. So that means our generic formula is going to be CXHYOZ. And we want to figure out all these. Now, we are given percents, so we need to convert from percents to mass. So if we have 50% carbon, and let's say we had 100 grams, that would mean we would have 50 grams of that being carbon. Our 5.5% hydrogen would be 5.5 grams of hydrogen. And if we had 44.5% oxygen, well, then that would be 44.5 grams oxygen. Once we have the masses, we can convert to moles. And we do this with the molar masses. These are what we find on the periodic table. So for instance, for carbon, it's 12.01 grams is 1 mole. And that's going to give us 4.163 moles carbon. We have 5.5 grams hydrogen. The molar mass for hydrogen is 1.008. And that's going to get us 5.456 moles hydrogen. And then we do the same thing for our oxygen. Oxygen is 16.00 grams is 1 mole from the periodic table. And so that's going to get us 2.781 moles of oxygen. So now we have the number of moles of carbon, hydrogen, and oxygen. So now we can go ahead and we can try to figure out the empirical formula. But before we do this, we need to realize that we can't just plug these 3 numbers in for X, Y, and Z because they have to be whole numbers. So what do? We divide by the smallest of the 3. And so that is the oxygen. All right, so that means I go ahead and I take this, I divide by 2.781. That's going to give me 1.497. I divide 5.456 by 2.781. and that's going to give me 1.962. And then I do the same thing for my oxygen. Obviously, 2.781 divided by 2.781 is 1. So now I have three numbers. Now, one of these obviously is a whole number, but notice the other two. Well, the hydrogen, we have 1.962, so that's very close to 2. The carbon is 1.497. That's not close to 1, it's not close to 2, but it is really close to 1.5. So we could plug these in and we'd get C 1.5, hydrogen 2, oxygen 1. But that's not a good empirical formula. Why? Because they have to be whole numbers. So what we need to do is we need to realize that 1.5 is the same as 3 over 2. So what we're going to do is we're going to multiply all of these by 2 to get whole numbers. C3H4O2. That is our empirical formula. Remember, the empirical formula is the simplest whole number ratio of each one of the elements. Next, we want to go ahead and we need to figure out the molecular formula. How do we do this? Well, what we need to realize is that go from the empirical formula to the molecular formula, we're just going to multiply by some number n. That can either be 1, 2, 3. So my molecular formula could be C3H4O2 or C6H8O3 or C9H12O4. This would be this is 4 and this is 6. This would be multiplying by 2, by 1, by 2, or by 3. And so what we need to do is we need to figure out what n is. So how do we find n? Well, to find n, we take the molecular mass and we divide by the empirical mass. What's the empirical mass? The empirical mass is the mass of our empirical formula. So let's figure out what that is. That is 3 times 12.01 plus 4 times 1.008 plus 2 times 16, and that's going to get us 72.062. So now we take the molecular mass, which is given to us as 144, we divide by 72.062, and that gives us for n 1.998, or 2. And so that means that n is 2. And so that means I multiply each one of these numbers by 2 to get a molecular formula of C6H8O4. That is my molecular formula. Let's go ahead and look at one other problem. In the problem we just did, we were given percents. We were told we have 50% carbon, 5.5% hydrogen, and 44.5% oxygen. So the first step was to go from percent to mass, and then from mass to moles. Well, what if we had the problem, but instead of giving us percents, they gave us the grams of carbon, the grams of hydrogen, and the grams of oxygen? Well, in that case, we already have the mass, so we just convert that right to moles. Right? So if we're given percent, we convert to mass, but if we're given mass of each element, we just go ahead and we convert to moles right away.